Hello, 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 everybody, and welcome back. Welcome back indeed, or if you're joining me for the very first time, welcome, welcome. We're looking at question number 13 on the 2002 Fermat paper, and if this is your first time, you can download a copy of this contest by clicking the link in the description. Okay? So without further ado, let's get right down to it. What was question number 13? A double single number is a three-digit number made up of two identical digits followed by a different digit. For example, 553 is a double single number. Two identical digits followed by a different digit, a digit that is not 5. How many double single numbers are there between 100 and 1000? All right. So this strikes me as working out some cases. So, I'm going to give names to the digits. Usually something that I do when it's talking about the types of digits. So if we were talking about a random 3-digit number, I might call it ABC if we were concerned with the digit specifically. So if we wanted this to be a multiple of 3, we'd know that A plus B plus C has got to be divisible by 3. Things like that. So when we're talking about a certain digit number being divisible by 11 or 9 or something, I usually write it out like this. Now, I'm given a particular pattern for the digits here, these double single numbers. So I'm going to write AAB be a double single number. So A and B are digits. I'm not multiplying A times B. A is the hundreds digit, A is the tens digit, and B is the units digit. Now, we want to sort of narrow down our possibilities of what pairs AB can we have, because then we can count them, and that'll tell us how many double single numbers we have. Okay, so the first thing I remember is we have two identical numbers, followed by a different number. So, first thing I'm going to say is A cannot be B. All right. And another thing I notice is, well, A and B, they're single digits, but A cannot be 0. Since it is a leading digit. Right, if A were 0, we could have something like 001, but you would not say that 001 is a 3-digit number. It's a 1-digit number. So that's why A can't be 0. Other than that, I don't see any restrictions on A. So that means A can be 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 choices for A. And once we make that choice of A, we have certain values that B can and cannot be. So once we make our choice of A, like suppose we chose A as 1. What values of B can we have? Well, we could have B be 0. B is not a leading number, so it's perfectly allowed to be 0. So I guess people might have forgotten that one. So there's probably an answer that doesn't include B equals 0. Now, B can't be 1. But there's no reason B can't be 2, 3, 4, 5, 6, 7, 8, or 9. We get double single digits in each of these cases. You can check them all out. In fact, for any choice of A, there are 9 choices for B. B can be 0. B will always be allowed to be 0. And then it can keep going until we hit it can't be A. So it can't be A, but we can keep going, and then we can get up to 9. So this is 10 numbers, all 10 digits, but we remove the digit that A is, and that's 9 choices for B. So in total, we have 9 choices for A, and 9 choices for B once we've chosen an A. So we can multiply these two together and we get all pairs A, B, and that gives us a final answer of 81. Now, if we hadn't realized, well, B can be 0, just because A can't be 0 doesn't mean B can't be 0, we would have an 8 here, and we would have gotten an answer of 72. And 72 is one of the possible answers. So hopefully you guys didn't get tripped up on that, although if you did, hopefully now you understand why the answer is actually A, 81. Okay. In the next video, the very next video, we're going to take a look at question number 14. I hope to see you guys there, and I hope you're enjoying the 2002 Fermat paper.